aldol condensation. Okay, aldehyde and ketone having alpha hydrogen can give aldol condensation. That's what we have seen in the last class. Okay, I was asking why only alpha hydrogen? Why can't the compound having beta hydrogens, okay, can give aldol? Why only alpha carbon and alpha hydrogen are compulsory for the aldol condensation reaction? I hope my question is clear and now audible to everyone. Yeah,
Yes,
Mario. Yeah, so tell me why alpha hydrogen is of such, why?
because it's a hydrogen is needed to form the bond.
So why can't beta hydrogen participate? Why only alpha? This is alpha carbon, right? Yeah, Marwa, any idea? What's so special in alpha carbon? Why not beta? The reason is the alpha hydrogen is acidic. Beta hydrogen is not acidic. So alpha hydrogen is acidic. Beta is not acidic. So alpha hydrogen can be removed. It can lead to the formation of a carbon ion, which act as a nucleophile. So why alpha hydrogen is acidic? Because the minus which is formed after the removal of alpha hydrogen, that can stabilize itself by undergoing resonance with the carbon double bond oxygen. Being adjacent to it, it can come on oxygen. You can see these two structures. Is it clear or not? Getting a point?
Yes, sir.
And that's how the reaction start. The alpha carbon get itself joined to the carbon of the C double bond of carbon carbon bond formation. OH and OH is there. That C double bond O changes to OH. And if heat is there, that OH and H are also. I hope it is clear to all of you. Okay. So let's discuss crossed aldol condensation. What do you mean by crossed aldol condensation? Till now we were looking at self aldol. Clear? And now we are looking at crossed. So why? What is crossed aldol? Marwa, tell me. Aisha, Jaslin. Crossed means what? It is between two different types of aldehyde. Till now we have taken just one type of molecule. Suppose, for example, if we take acetaldehyde and propanol. Is it clear?
Yes, sir.
So it is going to be, this type of aldol condensation is going to be crossed aldol condensation. Okay. So you have one type of alpha carbon, another type of alpha carbon, because you have two different types of alpha carbon, and how you should form the product, that also is very easy. Write both the aldehydes and side by side write the carbon ions which are formed by the removal of the H plus at alpha carbon. So this is one of the carbon ion. Got it? And this is another carbon ion which can form by the removal of alpha hydrogen from propanol. Getting my point or not? We are writing them side by side, just we are preparing to combine them. Okay. So this acetaldehyde can combine with acetaldehyde, or it can combine with the propanol. If acetaldehyde combines with acetaldehyde, we end up with this. This will change to OH. Look very carefully. If anything is not clear, do tell me, inform me, stop me. I will explain it again. Okay, this is the molecule. I have drawn a dotted line just to show you that one acetaldehyde is getting attached on the carbonyl of another acetaldehyde. Similarly, there is a propanol, and that can react, that can be attacked. CO can be attacked by acetaldehyde. Got it? So the first one is a self product. The second one, the one which is on the written on the right hand side, is a cross product because it is formed by combination of two different types of aldehyde. Got it? Then again, we need to consider the propanol. The propanol can react with acetaldehyde. That is going to be the cross product. Marwa, are you getting? How am I writing the products?
Yes.
This is I'm putting a line to show you who has joined to whom, right? And both the yellow products have written. Got it? Is it clear? I think I made a mistake. Yeah, now it is okay. This is the self product of acetaldehyde, the lower left, where the propanol, self product of the propanol, where the carbonyl alpha carbon of the propanol is getting joined itself to the propanol, CO. And the lower right is the cross product, because it is, so it is not only that every time you have the self product only, you, if you take two different aldehydes, they can react among themselves and they can react with each other. Okay, if they react among themselves, they will form the self product, and if they react with each other, they are going to form the cross product. Got it? Is it clear? The yellow one are formed when the carbanion alpha carbon of the propanol attacks on the CH3CHO. Is it clear or not?
So won't the double bond O break in the reaction?
Double bond,
C double bond O.
yeah, C double bond, oh yeah, that has already been broken. Where? This was double bond O. Got it? Can you see this?
Yes.
So it was before, in the original molecule, these were double bond O's. And because these alpha carbon join to this double bond O, they have changed to single bond OH. Got it? Any doubts on this? All products you should be able to write with clarity. Jesslyn, is it clear?
Yes, sir.
Okay. Now, and if they give you heat, okay, if they give you OH minus dilute, just leave it on the OH. If they give you heat, remove the OH and H. OH, you can see it is on the beta carbon. Beta hydroxyaldehydes and ketones. Beta hydroxyaldehydes and ketones are the product of aldol condensation. And if heat is given, you are going to remove the OH and H, you are going to remove the water. So the final products are going to be like this. So we have these four products as the final answers, which are alpha, beta, unsaturated aldehyde and ketone, and these four products with the double bond between alpha and beta carbon you are going to form if the heat is given. Getting my point? Any doubts on this? So just let me ask you one final question of intramolecular, not intra, crossed aldol condensation. Okay. And this is one of the most common questions. You have to tell me the final answers directly. You can tell me, I will write. So first you can try in 1 or 2 minutes. I can help you out that this is having alpha carbon and alpha hydrogen.
So that's acetaldehyde.
And that is acetaldehyde and this is benzaldehyde. This doesn't have any alpha hydrogen. Got it? Alpha carbon is there. I will write the structure, but there is no hydrogen. Okay, at this point. So this question is very important and easier than the above one. So acetaldehyde and benzaldehyde. Okay. What are the products which are formed when they are treated with base in the presence of heat?
We don't get a stable product.
No, we will get the stable product because there is a benzene. Hmm.
So benzene with
Hmm. Yes, benzene, pH, right? Then CH.
CH,
Hmm.
CH2.
CH2. Okay.
We also get an OH group.
OH group of that benzaldehyde. Yes, absolutely.
And then C double bond OH.
Yeah, am I audible?
Yes.
Yeah, just a second. Let me share the screen. So, by the time I share my screen, let me. Two products are there. Okay, one is the cross product and another is a self product. Self product is formed when the two acetaldehyde are combined with each other. Got it? Clear? And the cross product is formed when the acetaldehyde and the benzaldehyde combine with each other. Got it? Is it clear or not? So just a second.
So the CH has OH group, right, on the top. So doesn't it make it unstable?
Yeah, but ultimately, in the presence of heat, the water will get removed. Okay, so ultimately, finally, it will get stabilized. Yeah, till you have OH, it is reversible. Got it?
Yes.
Till OH is there, the reversibility is there. Okay, so that's why we call it as less stable. Got it? And when the OH is when you heat it, but in this case, we because of the benzene, the OH will be removed. Got it? And ultimately, you will have the final product. Okay, which is stable. Got it?
Yes, sir.
Okay. Yeah. Just I'm waiting for. Actually, I'm not host of this. The iPad is not the host account, so I'm trying to. Yeah. Okay. So I now we can see the screen. Got it. So this is clear. So we have a cross product. Okay, that pH, OH, until we have the OH. So it is reversible. Okay, so that's why we say that it is less stable. Okay, but because of the heating, this OH and H will get removed. So ultimately, you will have this as your product. Got it?
Yes, sir.
This is the crossed, and this is the self. Crossed aldol and self aldol condensation reaction. But if somebody has given two different aldehydes, then what must be the purpose of that two different, but taking two different aldehydes, it must be crossed aldehyde. Okay. So you can see that when the two different aldehydes are given to you, you must go for the formation of crossed aldol product as the major product. Is it clear? Getting my point?
Yes, sir.
Okay. So this is clear, and then we have so aldol alpha hydrogen is important. Okay, and in case of benzene, even if the heat is not given, you can make the double bond because the presence of, like in this case, okay, alpha hydrogen is must. That's we have seen, and okay, the the aldehyde or ketones which do not possess any alpha hydrogen. Okay, they are basically they will not give aldol condensation. They will give Kenizar. Okay, so let's move ahead with another reaction, and okay. Another reaction, two reactions which we have are aldol and Kenizar. Okay, uh, so this I hope it is clear. The crossed aldol condensation is clear. Prefer to form the cross aldol first. Okay. The next reaction is the Cannizzaro reaction. And the first and the foremost thing is Cannizzaro reaction is given by those aldehydes and ketones which do not possess any alpha hydrogen. Okay. For example, formaldehyde. Will it give aldol or Cannizzaro? Benzaldehyde. Will it give aldol or Cannizzaro? Do they possess alpha hydrogen?
No.
They do not possess any alpha hydrogen. They will give Cannizzaro. But if they give Cannizzaro, how come the benzaldehyde has given aldol condensation in the above example? It is because the other aldehyde was present. Is it clear? The other aldehyde is CH3 acetaldehyde, CH3CHO, which had alpha hydrogen. So in aldol condensation, at least one of the aldehyde should possess alpha hydrogen. Okay. And if there is no alpha hydrogen at all, then the reaction is going to be the Cannizzaro reaction. Got it? Is it clear or not?
Yes, sir.
Okay, so these are the brand ambassadors of Cannizzaro reaction. Okay, because whenever you study Cannizzaro reaction in any book, you will find these reactants. Okay, the one is the formaldehyde, benzaldehyde, and this is pyrroldehyde. Okay, TBUCHO. This doesn't have any alpha hydrogen. You can see. Okay, and then you have A lot of other molecules, but not very famous. These three are the most famous. Okay. This also doesn't have any alpha atom. This is the alpha carbon and it is already bonded by 4 bonds, so there is no place for any hydrogen. Got it? Clear or not? So what happens in Canizaro? Canizaro is very simple, not difficult like aldol condensation, and you do not have to make a carbon-carbon bond. Got it? Formation of product is very simple in Canizaro. Okay, the reagent is base, concentrated base. There, the reaction can aldol can occur with dilute base. Canizaro require concentrated base. Okay, formation of product is very simple, much simpler than your aldol condensation, because aldol you were trying to make a carbon-carbon bond. So there you need to be very careful that the alpha carbon need to be joined to the CO. You cannot join any two carbon atoms randomly. Got it? So, but in Canizaro reaction, how to write the product? Can any one of you tell me if you have studied? Though I will tell you. Yeah, any one of you can try. Jaslene, Marwa, Aisha. How to write the product in Canizaro reaction? Hmm.
So one of the molecules, they're reduced to alcohol,
Yes.
and
And another god will get,
carboxylic acid.
yeah, oxidize. Okay. So it is a redox reaction, disproportionation. Got it. So one will reduce to alcohol. Alcohol will be CH3OH. Okay. Another will be oxidized higher to carboxylic acid, which is of, because we had started with aldehyde of one carbon. This is the carboxylic acid. Got it. HCOONA. Because it is a basic medium, I'm not writing directly the carboxylic acid. Got it? Is it clear or not? Getting a point?
Yes, sir.
Okay. So very easy to write the product. For example, if you take benzaldehyde, it is not necessary that every time you will be provided with two molecules. Sometimes the examiner can give you just one molecule and just the reagent. Okay, you need to understand that this is the molecule which do not possess any alpha hydrogen. Got it? So what you need to do, you need to do the Canizaro. Getting a point? So just
Yes.
be very careful. Canizaro, we are going to make CH2OH benzyl alcohol and benzoate or benzoic acid. Clear or not? Benzyl alcohol and benzoic acid. So these are the two very easy to write the reaction. if any complex aldehyde is given, don't get intimidated by the structure. Very simple. You need just to know that this is the aldehyde which do not have any, the alpha carbon is there, but it doesn't have any hydrogen. Okay, so it is going to give you the aldol condensation reaction. Got it? Sorry, Cannizzaro reaction, not aldol condensation reaction. So the product formation is very simple. Just keep the remaining part as it is. And in Cannizzaro, what you do? You make one of the aldehyde as alcohol, another aldehyde molecule is converted to carboxylic acid. Okay. Very easy to write the product. Clear? The problem may little bit appear when you have cross Cannizzaro reaction. What do you mean by cross Cannizzaro reaction?
Different molecules of aldehyde.
Yeah, different molecule of aldehyde, two different molecules, and none of them possess any alpha hydrogen. Okay. If any one of them has alpha hydrogen, then they will start getting combined to each other. Got it? So none of them possess any alpha hydrogen. Okay, and what you will do cross Cannizzaro, but cross Cannizzaro will pose a little bit challenge to us. Okay, it is between two different aldehyde and both of them do not possess any alpha hydrogen. Now, one thing will come to your mind that whom should be oxidized and whom should be reduced. Got it? Is it clear? So one should get oxidized, the other should get reduced, right? But the problem is who should get oxidized and who should get reduced. Okay, that's the main problem. So I'm following both the options. This is one option which is in which I have reduced the benzaldehyde and oxidize the formaldehyde to sodium formate, or I can oxidize the benzaldehyde to benzoic acid and reduce the formaldehyde to methanol. Getting my point or not?
Sir, can you explain this again?
No, but which is the right? Only one option is correct, another is incorrect. Only one is correct. Which one is correct option? Getting my point? So which is the correct option that we need to understand? And there is a thumb rule. That thumb rule says uh, whenever you have a formaldehyde, it is always the formaldehyde molecule which will get oxidized. Getting my point or not? Got it? So the
Yes.
first option is the right and second option is incorrect. Clear? So always the formaldehyde molecule will get oxidized, right? If you have formaldehyde, the formaldehyde molecule will get oxidized. Got it? I hope this is clear. In cross Cannizzaro reaction, always keep this in mind. All your questions will be correct, right? Next is, so suppose I will take one more question. This is CHO, pyraldehyde. Okay, the common name is mentioned in NCERT, so you have to be careful. Okay, this is pyraldehyde and formaldehyde. Got it? I have taken both of them, right? Pyraldehyde and formaldehyde. When they are taken together and treated with a base, what will happen to them? Yeah, tell me. What will happen? Does any one of them possess alpha hydrogen? Hmm? Yes or no?
No.
No. None of them possess alpha hydrogen. So Cannizzaro will happen. Got it? Cannizzaro, one will get oxidized, another will get reduced. Got it? Who will get oxidized? It is always the formaldehyde which will get oxidized. Got it?
So, sir, this is cross.
Yeah, it is cross Cannizzaro. Got it?
Yes.
Because we have taken two different aldehydes, so it is crossed. In crossed, you may be having a doubt which one should get oxidized and which one should get reduced. So just keep in mind that it is the formaldehyde which is going to get oxidized. Getting my point or not? Clear? And the other one will get reduced. CH2OH. Clear? Any doubts? Now let's come to the detection of aldehyde and ketone. Though we have discussed a lot of questions related to the detection of aldehyde and differentiation. Just like we have discussed till now, if I summarize 2,4-DNP test. So 2,4-DNP test, it was reaction with ammonia derivative, where the C double bond O and NH2 combine with each other by removal of water. And the compounds formed are bright yellow, orange, red colored crystalline solids. Okay. So, but all aldehydes and ketone give the test. So it is not the test which can be used to differentiate aldehydes from ketones, but both aldehyde ketones can be differentiated from other functional groups. Got it? We have discussed addition of NHSO3. NHSO3 actually is basically, but sodium bisulfite addition aldehydes give the test. Ketones also give that test. Okay, some of the ketones. So we can't use it universally to differentiate between aldehydes and ketones from each other. Got it? Haloform we have seen. Haloform ketones, aldehyde both can give if they have methyl group. So generally we cannot use it to differentiate aldehydes from ketone. We need to find some reaction which can differentiate aldehydes and ketones. So what are those reactions which can be used to differentiate whether you have taken an aldehyde or a ketone? Tell me.
There's Fehling's test and tolerance region.
Yeah, tolerance and Fillings test. Yes. So tolerance test. What is the other name for the tolerance test? Yeah, Marwa. What is the other name? Jaslin. It is known as silver mirror test. Got it? And the tolerance reagent is ammonical silver nitrate. Okay. So aldehydes have this hydrogen connected directly to CO. Got it? And because they have this directly connected hydrogen to CO, this is known as reducing hydrogen. It means that this hydrogen can itself get oxidized and reduce others. Got it? So if you react this aldehyde with ammonical silver nitrate, which is having Ag plus, okay, this is a complex, coordination complex, diamine silver 1 ion. Okay, coordination we have already studied. Okay, what happened? This CH, which is known as reducing H, got it, will get oxidized to carboxylic acid because it is basic medium. So I will not write OH, I will write O minus. And if this get oxidized, who get reduced? Getting a point. Who will be reduced? Yeah, just like Marwa, Aisha, who will get reduced if the aldehyde get oxidized by Tollens reagent? It is the silver which is getting reduced, Ag plus getting reduced to Ag. Okay. And this get deposited on the walls of the test tube. That's why the name silver mirror test. Got it? Is it clear or not?
Yes, sir.
But ketones do not give this test. Why? What reason will you say? Somebody may write it like this, so don't get confused. Ammonical silver nitrate. AgNO3 mixed in ammonia. Got it?
Yes.
So what is the outcome?
CH3
Hmm.
CO double bond O
Hmm.
NH4.
Yeah. Then what will happen to the ketone? That's what I'm asking. The ketone, will it get affected or not?
Oh yeah, it can be ketones can't be easily oxidized.
Yeah. Because ketones do not have any alpha hydrogen. Got it? Or no, or the reducing hydrogen, not alpha hydrogen. Because there is no hydrogen directly linked to C double bond. Got the point or not?
Yes.
Because there is no hydrogen directly linked to C double bond O, there is no reducing hydrogen. So ketones will not be oxidized by Tollens reagent and they will not respond to silver mirror test. No silver mirror formation is there. Got it? Is it clear or not? Next is uh, Felling's test and Benedict's test. So Felling's test is also the same and based on the same principle that aldehydes have reducing H. Okay, the H which is connected to C double bond O, and they can react with the Fehling solution. While ketones, because in ketones we have carbon on both the sides of CO, so ketone do not have that reducing hydrogen connected to CO. So ketones will not give this test. Okay. So aldehydes can give this test. Aliphatic aldehyde. This is also a very important thing which you need to keep in mind. And it can be asked in your school viva also. Got it? First of all, what is Felling's reagent? Anybody? What is Felling's reagent?
CH4
Hmm?
copper
Yeah,
sulfate.
yeah. It is actually made up of A and B. Got it? There are two solutions. A is copper sulfate and the B is alkaline sodium potassium tartrate. Okay. So actually you need to have some basic medium. So sodium potassium tartrate. And this is also known by the name of Rochley's salt. Okay, they are mixed together to form the Felling solution. Actually, this is basic. These both of these tests, whether it is the tolerance test, that is basic in basic medium with ammonia into it. Okay, this is also in the basic medium. Okay. Initially, it is blue in color. Okay, and if you take aldehyde, what will happen? If you take any aldehyde, the aldehyde will get oxidized to RCOO minus, and the copper will get reduced. This is copper 2 plus, got it? Copper 2 plus is blue. It will get reduced to cuprous ion, Cu plus. Got it? The cuprous ion exists in the form of Cu2O, which is a brick red precipitate. Getting a point or not?
Yes.
What will happen with, but this is the warning which you should keep in mind, everybody should keep in mind. Aromatic aldehydes will not give this test because aromatic aldehydes are more stable due to resonance between the carbonyl and the benzene ring. They will not respond to this test. These are the exceptions. Is it clear? So very important to notice that aromatic aldehyde will not give this test. Got it? Then you have ketones. Ketones, we didn't expect ketones to give this test, and ketones will not respond to this test because ketones cannot be oxidized. If one is oxidized, other is reduced, and it is the copper 2 plus getting reduced to Cu2O. What is the color of Cu2O?
Red.
Yeah, reddish brown. Got it? Precipitate or brick red PPT. Clear? That reddish brown brick red PPT. And the formation of this brick red PPT signals the presence of aldehyde. Ketones will not give this test because ketones do not contain any reducing hydrogen. I hope this is clear to all of you. In Benedict, it's same copper 2 plus. The outcome is same. It is complex with citric acid, citrate. Okay. So I hope all of you can understand this. Next is shifts test. There is Shift base. Okay, Shift base is formed in when you react the aldehyde or ketone with NH2R. That is Shift base. Shift's reagent is para-rosanilene hydrochloride. That is one carbon, and that carbon is actually connected to benzene rings. Got it? 3 benzene rings. Okay, and NH2 group. So, but its structure is not important. The test is very simple. This is pink colored. You pass SO2 through it. It becomes colorless. And aldehydes can restore the pink color of the Schiff's reagent. while ketones cannot restore a pink color. Got it? So, but the other two reagents are very, very important. Okay, so now we can summarize all the tests which we have studied. Okay, including the one which we have studied now. Got it? So I will write the aldehyde CH3CHO. I will take some aldehyde, some common ketone CH3CO CH3, and an aromatic aldehyde benzaldehyde, and I take 3 pentanol. Okay, 4 aldehydes and ketones I have taken. Got it? So who will react with? Hmm.
Acetaldehyde.
Acetaldehyde, will it react? What will be the outcome? How will you know that it has reacted? Because it is a laboratory test, you should be ready to answer the observation. Got it? Is it clear or not?
Yes.
So what is the observation? If it reacts, what are we going to get?
Yellow precipitate.
Yeah, yellow precipitate of CHI3. Absolutely correct. Got it. Acetone also will give. Benzaldehyde will not give because it doesn't carry any CH3. Similarly, this 3-pentanone is also not going to get. Got it? Now NHSO3. Sodium bisulfite adduct formation. And what is the outcome? The outcome is the formation of crystalline solid. Got it? And who can react? Aldehyde can react, ketone can react, methyl ketone. Okay. But the ketone we do not have methyl group will not be able to react. Got it?
Yes.
2,4-DNP, right? 2,4, next is 2,4-DNP. So we are just trying to summarize all the reactions. Then we will move on to carboxylic acids. Okay. So 2,4-DNP, what is the outcome of the reaction with 2,4-DNP? Hmm. The outcome is the formation of bright orange red crystalline solid. Got it? Bright red orange colored crystalline solid. Is it clear? And who is going to give the positive outcome? All of them, because all are belong to aldehyde and ketone. So this test cannot differentiate between aldehydes and ketones. Got it? But aldehyde and ketones can be differentiated from rest of the other functional groups. Is it clear or not? Got it?
Yes.
Next is silver mirror test. Sometimes they just write Ag plus. Okay, it is AgNH3 whole twice plus or AgNO3 and ammonia, ammonical silver nitrate. Got it? So what is the answer to this? Who will give the positive test and who will not give the test? Marwa, tell me.
Yes, sir.
The first one, will it give or not?
Yes.
Acetaldehyde. Yes. Second one,
Mm,
does it
yes.
have hydrogen? No, it will not give. It is not an only aldehyde give it. You need to have H connected to CO. Got it?
Yes.
Benzaldehyde, will it give?
Yes.
Yeah, it is an aldehyde. So it will give. What about this one? This is the ketone, this will not give. Got it? Spellings test. Who will give the brick red PPT? Aldehyde will give. Ketone will not give. Aromatic aldehyde also will not give. This is an exception which you must remember. Ketone will not give. Ketone from ketone they will not give. That was expected. Okay. But aldehyde, aromatic aldehyde. Okay. That is also not giving is actually a bit surprising. Okay. That is exception. They do not give because of the less reactivity. Got it? Is it clear or not?
Yes.
Okay. So these are all the tests of your aldehyde and ketones. Okay. Let me ask you the structure of one of the compound. C4H8O. This is A. this when reacted with silver mirror test, Tollens reagent in silver mirror test, it, it will not form the precipitate of silver, it will give negative test. But with I2 and OH minus, this compound has given a yellow PPT of CHI3 along with another compound P. So what is the structure of A and B? That you need to tell. And what is the product formed when A is reacted with HCl? C. Getting my question?
Yes.
So first of all, this is 4 carbon. There is a double bond in aldehyde ketone. You know, that's why it is C4H8. 4 carbon can be, there are not many options. It can either be a ketone or an aldehyde. Got it? Is it clear? So it is not an aldehyde. And which option help us to make out that this, I will rule out the presence of aldehyde? Who's going to tell me that it is not an aldehyde? Which part of the reaction is telling me indirectly that this is not an aldehyde? It will not, it is not giving Tollens test. So because it is not giving Tollens test, it means it is a ketone. Okay. And there is one more thing which is helping us to make out that it is also, it can be a ketone because it is having 4 carbon atom and it is giving this iodoform test. So it must be like this. Got it? Because you have 4 carbon in total. So the other 2 carbon you need to put them in. Is it clear or not? And that is the only way. So 2-butanol is the answer. And what will happen if you react 2-butanol with HCl? That also is very simple. Clear? Now let's move on to carboxylic acid. I hope this question is clear to all of you. Okay. And this is the test, laboratory test. They can be asked in your school viva also. Okay, so be very careful. Clear? And this is the overall profile of this laboratory test. So let me start with the carboxylic acids. Okay. Nomenclature of carboxylic acids. Some common carboxylic acid you are already aware of. So we can start with this common carboxylic acid, and you need to tell me the common name and the IUPAC. This is another carboxylic acid, but with OH group. Got it? Hmm. Next, carboxylic acid. This is used in nylon, making nylon, right? 6,6. This is the carboxylic acid which is having a benzene ring in it. Okay. They all have their common names which are very common. Okay. And the IUPAC names also you need to know. Is it clear or not? Acetic acid you very well know. Ethanoic acid. Hmm. So just quickly tell me the common name and the IUPAC name of these carboxylic acids. Yeah, this carboxylic acid, all of you know, you must have used it in your practicals, school practicals. Yeah, Marwa, Jesleen. Which is this first carboxylic acid? What is the common name of this first carboxylic acid? Hmm. Yeah, Aisha, Jesleen, tell me which is this carboxylic acid, the first one?
Oxalic acid.
Yeah, oxalic acid. Absolutely correct. And what is the IUPAC name of this oxalic acid? Hmm. What is the IUPAC name? What is the word root? How many carbon atom it contain in its
Eth.
parent chain? Yeah,
Ethanol,
eth, in,
ethane,
and
ethyl,
yeah, ethane, and how many carboxylic acids are there too? So ethane 1,2-dicarboxylic acid. Got it? Is it clear or not?
Yes.
Dioic acid, right? Normally ethanoic acid, right? What is the suffix for carboxylic acid? It is oic acid for open chain, right? And carboxylic acid for cyclic if the COH is connected to directly to the cyclic ring. Okay, what is the name of this? Common name you all know, you are from bio PP. Okay, so all of you know it. Lactic acid. Got it? It is lactic acid, and this is 1, 2, 3. Propanoic acid. So 2-hydroxypropanoic acid. Is it clear? This is commonly known by the name of lactic acid. Getting my point or not? Marwa, Tesleen, is it clear? Aisha?
Yes.
Okay, what is the name for this one? Next one. Common name and the IUPAC name. Both of you can try. The common name is adipic acid. It is a dicarboxylic acid, just like the oxalic acid. Oxalic acid had no CH2 in middle of the two COH groups. Okay, just directly two COH group attached to each other. In an adipic acid, you have four CH2 in the middle and two carboxylic acids in the beginning and the end. So total 6. So hexane 1,6-dioic acid. Is it clear or not?
Yes.
This is benzoic acid. This is the common name, though it is already being used in IUPAC also. Benzoic acid, or if you want to go by the total formal name, that is benzene carboxylic acid. Got it? This is phthalic acid. Benzene 1,2-dioic acid. Phthalic acid is the common name. 1, 2. Cyclic you use carboxylic acid. Yeah, and oic acid you use for the open chain. Okay. So benzene 1,2-dicarboxylic acid. Got it? Is it clear? And it is commonly known by the name of phthalic acid. Okay, benzoic acid, benzene carboxylic acid. Adipic acid is hexane 1,6-dioic acid. Okay. So these are some of the common names. So let's continue it in the next class. The preparation of carboxylic acid. Okay. Meantime, you can go through all the conversions of aldehyde and ketones, including the aldol, Canizaro, okay, cyanohydrin, their laboratory test identification, and